Hello. The first algorithm in CPU scheduling algorithm is Fcfs scheduling algorithm, which is also called as first come first serve scheduling algorithm. Your first come first serve scheduling algorithm is non preemptive. So we already understood what is non preemptive in the previous video. So non preemptive means we are not giving up the CPU till a process completes its task. So this is called as your non preemptive. We'll learn your FCFS scheduling algorithm with an example problem. We'll consider a set of process whose arrival time and burst time is given below. We have to draw a Gantt chart and we have to calculate average waiting time. We have to calculate average waiting time and average turnaround time. As the name says, what is FCFS scheduling algorithm? FCFS scheduling algorithm is nothing but first come first serve. That means the process whoever arrived first will get the CPU first. Now before drawing the Gantt chart, we can maintain a ready queue to know who is the first process that have come to the ready queue first, so that the arrangement of the Gantt chart will be easier. Now let me write a ready queue on the left hand side here. Okay, now we have to see the arrival time. Now we have to consider arrival time from 0. So during 0 time we have only one process that has entered. That means P3 was the first process to enter the ready queue first, which had 0 arrival time. Since none of the other, now my CPU is empty, there is no other process inside my CPU. So I'll be allocating my P3 to the CPU. So P3 goes inside my CPU. And what is my burst time? Burst time is 3. That means my P3 process will stay inside my CPU for 3 milliseconds, from 0 to 1, 1 to 2, and till 3 it stays inside my CPU. So P3 completed its task. As we said, it's non preemptive. Till the completion of the task takes place, we are not giving up the process from the CPU. P3 had a task of 3 milliseconds, so we completed 3 milliseconds and we didn't give up the CPU. Now, we also need to know, is there any other process who came in that time where P3 was inside your CPU? So during 1 millisecond, we have to check the arrival time. There is no process who came. Now during the arrival time 2, again we have to check there is no other process who came inside the CPU during the arrival time 2. We have to check during the millisecond 3, there is no other process who came inside the CPU. That means there is no other process waiting in the ready queue. That means we have to ideally keep the CPU for almost a minute, since there are no other process available. Now during my 4th millisecond, there is a process called P1 who comes inside my ready queue. Now during P1 there is no other process, so I will be giving my P1 to the CPU. So P1 will go inside the CPU. P1 has a task of 5 milliseconds, that is 4 to 5, 5 to 6 is 2, 6 to 7 3, 4 and 9. So P1 completes its task till 9 millisecond, because from 3 if you add 5 it has to be 9. From 4th millisecond you are supposed to give 5 milliseconds to P1. So from 4 if you add 5 it will be 9. Now P1 completed the task. Now we have to see what are the other process who came in the meanwhile. Now during 5th millisecond we have P5 in the ready queue waiting. So after 5 we have 6. So during 6 who comes? During 6 there is P2 also, there is P4 also. Now when there is two process who are having the same arrival time, we have to check the order. P1, P2, P3, P4, P5. This order we have to check and we have to give according to the order. So P2 is lesser compared to your P4, the number, the order. So P2 goes inside your ready queue first, and then we will be giving to P4. Now after 6 we have to see 7th millisecond. So during 7th millisecond there is no process that came. Now we have to check whether 8, none of the process has come at 8 millisecond, and we have to check 9, none of the process has come. Now P1, P3 is already completed the task and it is out of the CPU. So P3 is done, correct? No, P3 is done. Now after that P1 also completed the task. So P1 is also done with the task. Now the leftover is P5, P2 and P4. So P2, P4 and P5. So these are the only process that was present, and we have already all the processes arrived. Now after P1 you have to see the order. Who came first? P5 came first. So you will be giving the CPU to P5. P2 and P4 remains in the ready queue in the same order. So P5 will go. We have to see what's the burst time given, 4. So from 9 we have to give 4 millisecond. That will be 9 to 10, 11, 12 and 13. So during 13th millisecond P5 will complete its task. So P5 is done. Now we have to give the CPU to P2. So P2 will go next and P4 will be waiting. So P2 will go here. So P2 had a burst time of 4. So from 13 we have to give 4 millisecond. That will be 14, 15, 16 and 17. That means at 17th millisecond P2 completes its task. So once P2 is done, what is the last process that is remaining inside the ready queue? We have P4. So P4 will go, and there is no other process, and there is also no other process left here. Now P4 will go inside the CPU. What's the burst time of P4? It is 2. That means 17 to 18 and 18 to 19 it completes the task. It completes the task. Now a Gantt chart look little messy because of the calculation that we have done. So it is fine if you write a proper Gantt chart after the final calculation. So first P3 went from when to when? 0 to 3 millisecond P3. Then 1 millisecond we were idle. That means the CPU was idle since there was no process for us to give the CPU. So the 3 to 4 millisecond my CPU was idle. From 4 P1 came and it used the CPU till 9 millisecond. From 9 millisecond P5 came and it used till 13th millisecond. After that P2 till 17 and P4 is your 19 millisecond. So this is the final Gantt chart. After the final Gantt chart, we have to calculate completion time, which is called as your CT. Then we have to calculate turnaround time, which will be written as TAT, and waiting time, that is WT. After that, we have to calculate average turnaround time and average waiting time. To calculate completion time, we have to check our Gantt chart. We have to see when was the process completed its task. So P1 completed at 9 millisecond. It will be 9. P2 completed at 17. P3 completed the task at 3 millisecond. P4 completed the task in 19 millisecond and P5 completed the task at 13th millisecond. Now we have to calculate waiting time. The formula for waiting time is turnaround time minus burst time. Before that, we have to calculate turnaround time. First, we'll calculate turnaround time. The formula for turnaround time is CT minus AT. That is completion time minus arrival time. So completion time for P1 is 9. Arrival time is 4. The answer will be 5. Completion time is 17. Arrival time is 6. It will be 11. Completion time is 3 and arrival time is 0. The answer would be 3. 19 and 6 will be 13. 13 minus 5 will be 8. So this is the final turnaround time for every individual process. The next one we have to calculate is waiting time. The formula for waiting time is turnaround time minus the burst time. Turnaround time is given here. We have to minus this with the burst time. 5 minus 5 will be 0. 11 minus 4 will be 7. 3 minus 3 will be 0. 13 minus 2 will be 11. 8 minus 4 will be 4. This is your waiting time. We have to calculate average waiting time. For average turnaround time, 5, 11, 3, 13 and 8 divided by the number of process. We have 5 number of process, so it will be 5. It will be 40 divided by 5, and answer will be 8 units. And average waiting time would be 0 plus 7 plus 0 plus 11 plus 4 divided by 5, that is 22 divided by 5. The answer will be 4.4 units. So this is your average turnaround time and average waiting time. Fcfs scheduling is a non-preemptive scheduling algorithm where if you see the Gantt chart, once a process enters the CPU, it makes sure it completes its task and then only it is coming out of the CPU. So this is called as Fcfs non-preemptive scheduling algorithm. Thank you. I will continue with shortest job scheduling algorithm, both preemptive and non-preemptive, in coming videos.